Hello, calculus fans. Okay, so we want to know what is the closest point on the parabola to the point 0, 1. Now, at first glance, you might say, well, maybe it's right here at the origin. But as we're going to find out, there's actually some other point along the parabola that's a little bit closer. If you're at the origin, you can see that you're 1 unit away. But we're going to see that there's actually a point somewhere along in here which is a little bit closer. Okay, so the way we're going to do this is we're going to let P of xy be an arbitrary point on the parabola. Now we know that on the parabola y is equal to x squared, so we can say that this point is x comma x squared. Now we have a distance formula that gives us the distance between any 2 points, x1, y1 and x2, y2. It looks like this. So the distance formula looks like the square root of x2 minus x1 squared plus y2 minus y1 squared. And keep in mind this is just a byproduct of the Pythagorean theorem. So then we can write down an expression for the distance between P and Q. And it's going to look like this. So our point P is x squared. The point Q is 0, 1. If we plug those into the distance formula, we get the square root of x minus 0 quantity squared plus x squared minus 1 quantity squared. Let's clean up the radicand. I used radicand. That's the word that means the thing that's inside the radical. Okay, so if we multiply everything out, then we'll get x squared plus x to the fourth minus 2x squared plus 1. Let's clean this up just a little more, and we end up with this. So that's our distance formula. What that says is if we pick a point on the curve, which is x comma x squared, then the distance between that point and the point Q is square root of x to the fourth minus x squared plus 1. Now we're looking for an absolute minimum of this function on the domain minus infinity to infinity. See, the value of x is allowed to be anything. Now there has to be an absolute minimum. The geometry of this problem definitely shows that there has to be a point somewhere on the curve that's closest to 0, 1. Okay, usual game. We'll take a derivative and set it equal to 0. So if we use the chain rule and the power rule, then we end up with this. D prime is 4x cubed minus 2x all over 2 times square root of x to the fourth minus x squared plus 1. And as usual, we're going to set the numerator equal to 0. So if we set the numerator equal to 0, we've got 4x cubed minus 2x equals 0. And if we factor that out and solve each piece, we're going to get 3 critical numbers, 0 and plus or minus root 2 over 2. Now, as usual, don't take my word for it. Take a little time, do a calculation, set this equal to 0, and see that you actually get plus or minus root 2 over 2. Now, because there has to be an absolute minimum, then this absolute minimum has to occur at one of these values. So we're going to go ahead and plug these numbers back into the original function that gives us the distance. All right, so we're plugging things back into the original function to see which one is smallest. Okay, so it looks worse than it is. Plug everything back in. Then for d of 0, we get 1. And for d of negative root 2 over 2 and d of root 2 over 2, we get square root of 3/4. This is, again, one of these things where you should not just trust my calculation. Do the work. Make sure that you actually get these numbers. Okay, now, what are we looking for? We're taking these 3 numbers here and saying, well, which one is smallest? Well, square root of 3/4 is smaller than 1. So that's the smallest value. So the absolute minimum occurs at plus or minus root 2 over 2. So it's actually 2 points that's closest. We can compute the corresponding y values. So those corresponding y values are just going to be 1/2. How do we get that? We go back and plug it into the equation of the parabola, y equals x squared. And again, you should plug those in and double check to make sure that when you square those numbers, you really get 1/2. Okay, so the closest point on the curve to the point Q are these 2 points, negative root 2 over 2 1/2 and root 2 over 2 1/2. So you can get a little bit close than 1 unit away, and it occurs at these 2 points. It's actually not surprising that there are 2 points. This curve is symmetric about the y-axis, so if there's a point in the first quadrant that's going to be closest, then the mirror image in the second quadrant should be also just as far away. Okay, that's all for now.